We leave the word and the picture to Laurent, and you'll tell us a little bit more about HampaKalk and how you work with it in France and so on.
Okay, thank you very much. Simon, how long time we take around for discussion and presentation?
Actually, I've said 1.5 hours,
Okay.
but if it takes 2, I have no problem. So
Okay.
if you're not available, you can drop off by yourself. So we see when the person's dropping off here.
Yeah, and for the discussion, I will try to make some short series of topics so that we can have discussion when anybody needs to ask questions.
Yeah.
Right. So I will start with a just short project, and we also I will also try to have some technical points about HampaKalk. But just to begin, I will start with a short, really short project. It was only 4 square meters in Paris for an exhibition. And we did it in 2 days. 1 day to build the wood frame and the HampaKalk, and the other day to just to split it on site. And so you see, Simon, you can do your own way and build your own home in your garden in almost 2 or 3 days.
Sounds good.
And this small project was first just in an exhibition about HampaKalk, and we met Ministry of the French government inside, so it was really interesting first. And after that, we bring this small building and transform it into a sauna in Paris for another place and another time. It was in winter, so we also built, as you see on the screen, another small prototype, which became hammam. And those 2 first experiments were really interesting for us, because we just start to make small experimentation. It was just another thing quite different from what we are used to do in our office. But then we tried to understand what could we do when people ask us to just demolish the small hammam, and we start with this question, a research project about the end of life of HampaKalk, and try to discover how we could transform the materials to not to leave it at the garbage, but find a way to reuse, recycle HampaKalk. So we bring the block of HampaKalk, and we take them in a huge machine. There is just a small picture, but it was incredibly used, and we break down the brick of HampaKalk, and we transform them in HampaKalk recycled to build a small project in Paris, and it's a way to try to experiment and confirm that we can reuse HampaKalk. This is really important. I just go back to this. Why is it important? So this is life cycle analysis of hempcrete. So you see two lines. Each line is correspond to one time of life cycle analysis of hempcrete. The first line is the recent one. It's when we get the last analysis in 2015, and the second line is the first analysis we achieved around 14 years ago. You see that global emissions of hempcrete is quite different. On the first line, it's positive. On the second line, it's negative. It depends on one point, which is how we can take in account the carbon catch by the plant. And on the first line, we consider that this carbon doesn't matter. We don't take it in account. And on the second line, we take it in account. And that's why we really are motivated to succeed to reuse at the end of one life the hempcrete to offer it a second life. This means that hempcrete will never be a garbage and could even if we demolish a building one day, maybe could be reused, so that the carbon will be catch in the plant for all the life cycle. We first met with hempcrete around 12 years ago in France, when we had a friend architect who asked us, as he was in charge of the refurbishment of an old building, he asked us whether common solutions were good for this old building. So we try with a short study in which we compare the common use. So we use in common way, we use polystyrene. I don't know the English word, but it's like
it's the same.
It's
polystyrene.
the same polystyrene. So that's it. Of 8 centimeters with a plasterboard. So this is the first detail here, and we try to find an alternative way to insulate these old walls, and we discover hempcrete then, and we propose to use hempcrete for inside insulation of the wall, and we complete it with a lime render with hemp also on the outside side of the wall. And you see that the color of the wall change. This means that the wall is warmer in the second solution. And also what was really different is in those diagram, you've got those two solutions which we compare. On the left, you have the solution with polystyrene. On the right, the solution with hempcrete. Globally, the calculation is exactly the same for both. We've got around 56,000 kilowatt-hours of all the energy loss in the buildings. But in the first solution, we get high insulation of the wall. This is the first column. And you see that this column is exactly the same that the yellow one, and the yellow one correspond to thermal bridging. So this means that in this solution, it's not balanced. You have in just around 20 centimeters each levels, you have also you have the same energy transfer than in 2.5 meters of the wall height. So it's incredible to think about it. So it means that the heat transfer in thermal bridge is around 10 times higher than in other parts of the world. And this means that it's easy to put polystyrene on the wall. It's not easy to put something to take the thermal bridge correctly in account. And that's the way I think we mainly in France used to think about energy efficiency. And the other way we proposed in this case was to probably be less efficiency on the wall part. You see the first column is a bit bigger, but as we also had a good solution to be able to put some insulation in the render, which was really important in this case, as it's an old building. This was able to reduce the thermal bridges, and the use of HampaKalk allow us also to reduce a bit the ventilation use, as the HampaKalk is able to make hygroscopic regulation. So humidity of the air can be absorbed by the wall, and it helps us to reduce ventilation use. So globally it's the same, but in fact it's totally different design of the climate inside the building.
Great to see. Very nice to see that.
Yeah, it's really important for us. Today, when we make life cycle analysis, we find here you've got all the consumption in the building process. So you have the first orange and yellow column, which are energy consumption in the building. The green one are energy production in the building. The blue one is energy embodied in the building, and the red is about moving in the city. And what is really interesting is that so we try to optimize each consumption, but when we reduce the consumption of in the building, we increase energy embodied in the building. And today we probably are at this point of balance, that energy consumption in the building is exactly the same than energy embodied in the building. That's why we have today to reduce energy, embodied energy, and bio-based material are really interesting for that.
Actually, I was listening to a scientist at LTH who was talking about insulation, and he said just about this, that we need to change the way we insulate our buildings, because we don't get any lower at the total energy consumption.
Yeah.
So we need to rethink that, because now when we make the energy consumption in the use of the building so low, we have standards in Sweden that is getting lower and lower. Then we need to put in more and more insulation that costs more than we gain.
Exactly.
So therefore we need to think about what kind of insulation and how we insulate our house. So it's exactly the same.
That is probably mine. Exactly. If I would just show you a really interesting document about this. It's a study from ETH de Zurich, which is the University of Zurich, and they just made a study to know how we could make an energy renovation of all buildings in Europe, and they compared different solutions. I just show you a small article. So wait just a minute. This is it. Okay, so this is a short paper about the study, but if you're interested, you can look for the study of maybe her name was Francesca Pito, I think. You've got here the reference. And in this study, toward a model of circular renovation of the existing building stock, they compare different solution. So you got the solution there. They compare 5 solutions. The first one was just bio-based prefabricated, so it's with wood wall. The second one is with hempcrete prefabricate. The third one is with mineral wall and wood wall. Sorry, the first one was with straw, not wood wall. So the third one is with wood wall and mineral wall. The fourth one is with hempcrete made on site, and the third one is with synthetic. And when we get the results, this is the results. So they achieved life cycle analysis. You can see that the results are done for 2,000 years. 200 years, yeah. And we get the result for, in red, it's for synthetic. In green is for the solution with wood wall. In blue, it's with hempcrete, prefabricated and on site, and the yellow one is with straw. And this shows that if we want, and it's just a global warming, so it's carbon emission of each solution, and this shows that straw is really good. The hempcrete will be globally negative in just 20. We take in account what I said tomorrow. What I said, sorry, at the beginning. If we are able to reuse the hempcrete, and I think it's really easier to reuse hempcrete than straw. The hempcrete should be really reduced more than it is on this diagram. But what is really important is that only straw or hempcrete, which are bio-based materials of high speed growing, are able to get the correct response to renovate the building stock in Europe. As you said, Simon, we have no choice. No, we just have to use this kind of materials.
Yeah.
So I go back to.
So it's not enough with just using the wood. It wouldn't be enough. It would take too long to.
Yeah, too long. Because of the growing of the
exactly.
The we have to use wood with the bio-based materials.
Yes.
Or reused materials.
Yes. Yeah. And actually, that was the same as the investigator in LTH. Because when we insulate more, it takes more energy to create and also this in the future. So you need.
So the passive houses, it's not the future.
It's not the future, no.
Yeah.
Excuse me, it's just a short reflection. This
We lost you, Felix.
You lost me again. Okay.
Yeah.
It's very interesting and so on, but you start on a level that is quite technical and all these parameters, and I get them. But could you start with on a lower level? Maybe I'm the only one here, but you are starting already with reusal of HampaKalk, which is certainly very interesting, and especially when you talk about it on a greater level. But how does it work in a more general way? Can you? Is this a stupid? It's a stupid question, but I'm not so familiar with the production or how it's done and the manufacturing process and all these things, you know.
Very good question.
It makes it easier to understand all the charts and all the parameters. I think it's the cold barrier thing is very interesting to me, but if I don't know the process before it, it's kind of hard to. Then I'm kind of guessing how does that really work, you know?
Yeah.
So a little bit about the process. Is that possible for you to do?
We're changing presenter.
Okay. Okay. Thank you. Maybe I'm the only one, and then just tell me, and I can look it up or something. But you know,
it's a very good question. Actually,
okay.
I think Michael has worked a little bit with HampaKalk, but otherwise,
so some
it's only
general.
me and Peter and Laurent who has seen it.
Yeah, we start. I'm starting to, you know, guessing the behind story, which is kind of it's not so good for me. Thank you.
You get it there.
Okay, HampaKalk basics. HampaKalk 101. We have three.
HampaKalk for dummies. Thank you.
We have three parts of that make up HampaKalk. You have the hemp sheaves, which is the inner part of the hemp plant, which is what you see at the top of the. Looks almost like small wood cuttings, and then you have.
And it's actually grown in Sweden nowadays as well, or
A
small amount is grown in Sweden. You have a larger amount in Denmark, and we are working very hard on having our own production, but it's a matter of machinery.
And what about it in France? Is it a big thing there?
Not as it could. In fact, if we just look 100 years ago, we had in France and probably in many countries, HampaKalk quite everywhere. So we had 200,000 hectares of hemp in France. Okay. And today we just have around
20,000.
20,000, yeah. 20,000 hectares. And it's if we look just maybe around 6 years ago, we just had around 10,000. So it's really increasing each year.
Okay, yeah.
But to put that into perspective, those 20,000 that France has, that's 40% of the European market. They are by far the largest producer of hemp in Europe.
Okay, yeah, okay.
And-
And it seems to, I mean, hemp seems to be such a super interesting product. It's usable in so many ways.
Yeah.
Yeah.
So it's, to me, it sounds incredibly interesting, actually. So yeah, thank you.
Okay, so we have the hemp sheaves, which is the inner part of the plant. We have lime, and it's a mixture in between hydraulic lime and air lime. And basically, we want to maximize the amount of air lime to keep the hydrothermal properties of hempcrete, to allow moisture to travel through the water or through the wall to have it.
And that's also a thing we have in Sweden. Quite
Yes.
Large amounts of lime.
Yes. And so here on, and then the water is just to create the chemical reaction with the lime.
Mm.
So on the picture, you see an old way of casting hempcrete, which is casting it around a wood frame. You always need a wood frame. It's self-bearing, but not load-bearing.
Yeah.
But one of the reasons why you call it hempcrete instead of concrete is that it's one monolithic wall from the inside to the outside, where you just render it with a lime on either side.
My reflection is, when I see hempcrete, I refer it a little bit to our traditional träulit.
Yeah.
Is that a stupid comparison, or is it somewhat something?
It's a fair comparison. I would just say that hempcrete is better in every possible way.
Well, of course.
Yeah,
but just to make a picture for
yes.
It looks very similar, but
and as I understand it, it does have some of the. I know that somebody did a project on this trail blocks which they were using, and it had some problems, and I would assume that those problems are a little bit comparable to what you will have if you build with hempcrete. I mean, how you mount things on it, and how you put windows in the constructions and so forth.
Windows isn't really an issue. You build the wood frame and you.
As you have the wood frame in this perspective,
Yeah.
okay. And you never use hempcrete as a block, because rheolite you can use as a block as well.
You can definitely use it as a block. They are making it more advanced. The problem has been with the blocks is that you need a larger amount of lime.
Yeah. Okay.
And also, when you do it with a normal mortar, you'll get the cold bridges where you have the mortar. However, they now are creating mortars that are made out of hempcrete.
Yeah.
So you get a monolithic wall.
So it's a sort of korsvirke construction, what do you say, wood frame construction thing, or as you describe it.
the difference between the korsvirke or the wood frame is that you see in the picture that the wood frame is all embedded in construction. So you don't have the visual wood if you don't want it.
But you can.
But you can if you want. Yeah.
Sure.
But that's one part, because then you gain that you don't have the large cold bridges and so on.
No, okay, yeah, right, and it doesn't as I mean, you don't have any. What about the? You will not have any problem with the wood in the process, because the lime is kind of conserving it, or?
Yeah, the lime conserves it. Yes.
Yeah. So that was part of my mansplaining guessing, and thank you for. In
addition, could you tell us the main difference why not using wood chips instead of hemp chips?
Hemp chips have the hemp you use for two main reasons. Hemp is the second fastest growing plant in the world after bamboo. So in a matter of months, you get a 4-meter high plant with a lot of biomass that absorbs a lot of CO2. The second reason is that the hemp shibs can absorb 5 times their own weight with water without taking any damage. So they work like a sponge, and that's the special characteristics.
And isn't fire
It also has
different?
It also has a high amount of silica, which helps it connect to the lime, and it also makes it more fire resistant. But especially when you mix it with the lime, you get a completely fire resistant product.
Okay. So I can see the better parts compared to the wood this träolit thing. Yeah.
And träolit is also with cement.
Yeah.
And so that makes it.
Of course. Really, of course. Yeah. It goes without saying. Yeah. And, yeah. But I mean, it's still there is some sort of, you get a picture of it and you understand it a little bit, you know, in some sort what it does, so to speak. Yeah. Okay.
So this is just a picture to show the fact that you can do prefab with it as well. So you can have a very fast, controlled construction.
Mm-hmm.
Here we're doing one picture with just the basic benefits of it. The weight is about 1/6 of concrete. You get a very energy efficient building. They have recently built a building in France in the spring of 2020 that was passive house standard, but only with bio-based, with hempcrete, among other things. Hempcrete and wood fiber. It's completely natural, and you have no toxins in the wall, so you're avoiding all plastics or fossil materials in the wall. By several estimates of university studies, that should have a lifespan of several hundred years. So you're talking about a building that has the possibility of standing a lot longer than what we create today with our modern materials.
And then you can reuse it as well, which means that it's even better. Yeah, I get
exactly.
it.
It's completely fire resistant. They just had tests done this summer where it passed 4 hours without burning.
Oh. And
something that has become very popular among people living in the countryside is the fact that pests and rodents don't like it. So if you insulate your house with it, you avoid mice
and rats.
I
have it in my Topago just because I had rats there before. They are not
really? Okay. So does that have to do with? I mean, is that something with the hemp as a plant? Okay.
Not really the hemp as much as the lime, actually.
Yeah. Well, because I would say that that would be the same with this. Yeah. Okay. Interesting.
So just a picture of the hemp plant. And this is a very important part, is that 1 hectare of woods that grows absorbs about 5 tons of CO2 in a year. Whereas hempcrete, depending on the variation of the plant, because you have different plants that grow to different heights, absorbs in between 15 to 20 tons of CO2 per year.
Yeah.
And also, obviously, it's in a matter of 4 months, you can harvest the plant. So you don't have to wait for 25 years.
Oh, okay. Yeah.
As we talked about, there are several different aspects of the hemp plant that you can use. The hemp fiber for textile, for the interior of cars, and bioplastics.
Yeah.
And the superfood as well, the seeds of the hemp. It's a perfect mixture of omega-3, 6, and 9.
Yeah. There was an interesting program of Paul, this chef, who did some things on the for cooking, which was incredible. It's a tip. It's on some public television in Sweden if you want to see that. It's really interesting for you Swedish guys.
Yeah. And this is a picture of the hemp shiv very close up, where you see all the different pores of it, which is the ability to absorb and release moisture.
Yeah.
And in the French EPD, as well as the German, the EPD is the Environmental Product Declaration. Okay. They have indoor air quality, which is something we don't have in our Swedish EPD. but hempcrete gets the A+, the highest possible for interior air quality. And that's due to that it regulates the moisture levels. And I think that's about what I'm going to do with the 101. I'll leave you with this picture here where you see how you can insulate both the wall and the roof, and where they can meet each other to avoid thermal bridges.
Okay, yeah.
This is using a spray machine that can apply up to 6 cubic meters per hour. So it's quite efficient.
Okay. So what was your name?
Peter.
Peter, okay, thank you. Thank you. It makes it easier to get the picture to what you were saying, Mr. French guy, to get the background. Thank you.
Now you have a little bit more about the background. And, Laurent can keep on his presentation. Depending on who you're talking to, this different variables is important. And I think today, one of the most important things in Sweden, at least, is the energy consumption that we need to, that we can work with it and how it works for the environment and then. But of course, it's very important that it has the durability of mounting and how we use it and so on. So very good question and very good presentation about the background.
Well, thank you.
Okay, if we go a bit forward about hempcrete, as Peter said, we have chive lime and water and air also, and you have here two small drawing about two different type of hempcrete. On the left side is the insulated insulation with hempcrete. So we will try to have the less lime we can, just to glue together all the shears. And on the right side is the render with lime render with hemp. So it's the insulated lime render, which is quite different because we put inside much more lime, just to be more able to protect the wall. So we can change the proportion of lime and hemp and make different kind of hempcrete. So I go. Here are the machine to spray hemp on the upper left, and the second machine is to spray the lime render, and we can use it in small building sites. As you see, it's near Notre Dame de Paris in the center of Paris. We just have a really short place, but we put the machine and we store the materials, and then we spray it with the machine and the lime and the sheaves that came into the tube, and they just mixed at the end before being sprayed on the wall. And as you see in the picture, we can put hempcrete directly on the wall without any board outside, just to be able to close the wall, and for the inside, the opposite side. We just use sometimes laser. You understand laser? Just and when we spray, the laser just told us when we get the correct thickness. And the hempcrete, what is really interesting is that the hempcrete just stay glued in the wall that directly.
Actually, I got that question from one of our builders that we were talking about it, and it just stayed there.
Yeah.
And I say, yeah, it does. It sounds like magic.
Yeah, it is.
Yeah.
And another interesting point is that we get with the machine today, we are able to go as fast as people use with concrete.
Yeah.
So we with this machine in France, they go fast, and sometimes in our building we during the work on site we stop them because they go too fast and we have to think on too many things.
Yeah.
And for example, they are able to spray from 8 to 20 cubic meter per day.
Okay.
So it's really
Quite a lot.
really quick. Quite.
But as I understand it, you are mixing the things on site, so they come as two different products, and you put them together on site. In this case.
Yes.
That's correct.
Yes. Yeah. I will show you some picture after that about pre-made or prefab wall with hempcrete. So this is the hempcrete. So you see the line is gray, and the hemp, the M shape with the line here. So we use water as said Peter. So we need after that time to let the water go out. It takes around 1 week for 1 or 2 centimeters. It depends on the weather, and this means that we today begin to work with prefabrication in France because it allows us to make the precast inside a building on special condition to be able to control the drying of the wall. This is the way also you can put the hempcrete by hand directly like traditional rendering. So it's really interesting. We can use many ways to put it on site or outside. An really interesting point is about how we feel in a building with hempcrete. So this is some houses we built around Paris about 4 years ago, and one day in the summer when we visit the building site, I came with my thermometers, and it was a hot day, and when we came in the building, there was no windows, no doors, but when we came inside, we feel really good because we feel like we came inside a ground cave, and so I take the measurement, and as you can see on the thermometer, we have the wall temperature, which is around 16 degrees, whereas the outside temperature was 30 degrees, and inside was around maybe 29 or something like that. So this is interesting because what we feel when we came in is a mix about the air temperature and the wall temperature. We feel both the air temperature as the air is in contact with our corpse, but also we feel the radiation of the wall and our perceived temperature is the mean of the air temperature and the wall temperature. In this case, we get 30 degree outside and 16 degrees for the wall temperature, which means that the perceived temperature was 23 degrees. So it's exactly like climatization. So we can, with this difference. Yeah.
But were the walls already dried out when you were inside? Because I think during the building process, because it's drying out, of course it will be cooler.
Yeah. It's a bit higher effect during the drying process. You're right.
Of course. Yeah.
But it's also you will see after that an important effect we will have with the hempcrete all the time.
Okay.
So here we get 7 degree decrease when we came inside. That's really important. But you're right, it's a bit more than usual time. Here we've got some diagram of research made by Mike Laurant in city of Bath, and he built a small prototype of around 20 square meters in the British research establishment, and there was no heating inside, and just make measurement of the temperature variation, humidity variation. So here you get the blue line, which is the wall temperature inside, and the red is the air temperature inside. So you can see that the wall temperature is each time a bit higher than air temperature. So which means that it's something happens with the wall, and the wall is able to create energy. In this second diagram, you can see the difference between the outside temperature in red and inside temperature in orange. And you can see both that the hempcrete is about to reduce the variation, the temperature variation each day. And important is that you can see that the mean temperature outside is under the mean temperature inside, which means that there is also an ability to create energy inside. Here you find the way it works in summer, and in summer you have here the difference between the air temperature outside and the air temperature inside. So air temperature outside is the blue one, temperature inside is the orange one, and with the red one you have the temperature of the outside side of the wall. So you understand that the hempcrete is about is able to evitate increasing temperature inside, and this shows the variation of humidity, relative humidity from outside to inside, and you understand that it's exactly the same. The hempcrete is able to make different variation of it. So if we go to this second experimentation made by still Mike Lawrence in Bath University, he just take a short wall of 1 square meters, and he put this wall between two different climates, and you see the upper diagram, which represents on the red line, sorry, on the green line on the left, the outside part of the wall, and the blue line is the inside wall, and we get inside, we get 20 degree for the inside temperature, and you see here it's the red line, and this red line show that the temperature in the wall decreased from 20 to 5 degree. 5 degree is the outside temperature, and the second line represents the relative humidity inside the wall and on the both parts, outside and inside. What is really interesting is that, sorry, is that you can see there the temperature inside the wall, as it is exactly the same product from inside to outside. It's just hempcrete. The temperature should have decreased directly. This is the physics law, but it starts to decrease and stop, and there is just a bit increase of temperature in the between in the first centimeters, and in the same time the humidity, the relative humidity is decreasing exactly in a symmetric way. This is really important. This means that in the wall there is heating created. There is a heat created, and in the meanwhile, in the same time, the humidity is absorbed in the wall. So when we go back to this picture, and the picture is quite better than mine, but you can see the hempcrete, the hemp here, with all the small cells around the big channels, and the small holes making connection between all these parts. So this is the way hempcrete can stir, and in the when the humidity go inside the wall, the temperature start to decrease, and whereas we should find condensation in the wall around usually we find it around from 10 to 12 degree. Here it happens around if we go back there, it happens around 16 or 17 degrees. So it happens really quickly, and the humidity is the steam is absorbed by hempcrete, which can store the water. So when we have it in the winter, we get creation of heat in the wall, which explain why the wall temperature is higher than the air temperature, because there is a creation of it inside the wall. And in the summer, we get the same effect, but symmetric, which means that the water in the hemp will evaporate, which will absorb the heat transferring in the wall. So this allows the wall to be colder than the air, and we observe that we can get from 3 to 5 degree decrease of temperature. This is the main point with hempcrete, which means that we have to design building able to let the steam cross the walls. And usually when we think about energy efficiency, we try to fight with the steam because the humidity is a problem with the mainly insulation system. But with hempcrete, it's quite different. And, it's really interesting because it's changed the way we will feel inside the building.
But it's vapor permeable, but airtight. So
yes,
it could be still passive standard.
Yeah, of course, of course, of course.
Cortex på bygge Cortex.
Yes.
I mean, it's super interesting. This is what I like about it also. The feel of getting in a house like that is fantastic, of course. I can get that.
I will now just show you some. There is an interesting book, if you don't know, the book of Lisa Echong, which is called Thermal Delight in Architecture. It's just a short book written in 1979. So it's quite old, but still so actual. And she talk about how we feel in the spaces and how our core can function, can work in the space using both our feeling and our culture and our psychic state. And we can design with all these questions when we use hempcrete or natural materials, because they are not neutral material. When we are inside in contact with this material, we feel that it's not usual space. I will not just show some projects, different projects. I will go a bit quick, but you can stop me if you have any question during the time, and I can just explain more different points if you need. This first project is a small house we built in the northwest of France. In this house, we built just wood, and we had hempcrete for all the roof and the walls, and we also have three small greenhouses included in the house. And you can see that we get a ventilation net crossing the walls, different walls, and in fact this is the section and the plan, and greenhouses are like the
like the lungs of the house, and they also work as heat exchangers.
Yes, thank you, Peter. It's meant that the house is able to have a respiration like us, using the greenhouses in which the air comes from the ground, taking the sun heat in the greenhouses, and then crossing different rooms until they go to the bathroom, where there is ventilators creating the aspiration. It was really interesting in this project because we built it around 8 years ago, and it's quite experimental houses. But we never heard again about our client. He just live in the house and seems to be quite happy of it. And what was really important for us is to combine the bio-based material and air special ventilation design. After that, we built a small first housing building in Paris. When we had to build this project, we was thinking about how to build in a dense town where you have quite no place for the building time. So we look in history, and we saw that in Paris we used first stone, because there was stone in the ground. So in Paris you find sometimes a big hole in the ground, and in fact people they just go down, they take the stone in the ground and up, and they make the building upside. It was like this in the past century. They also use wood frame as you and in many countries. And when we began with concrete, the concrete was also used at the beginning as a framework, like with the steel. And we decided to use exactly the same type of construction, but in a modern way for us. We use a steel frame, wood frame, and a hempcrete to fill the frame. So this is the first building we achieved in Paris, Rue Mira. You can see the finishing of the facade on the streets. It's a rendering.
Where is this located? Where?
It's in Paris, in the north of the city. Exactly, it's in the streets.
It's in the 18th neighborhood, just below the Sacré-Cœur.
Okay, 18th. Okay, thank you. Then I know.
And we get in the backyard wood finishing on the hempcrete. So we get the hempcrete for all the facade. You see the construction system. We use the steel frame and the wood frame filling the steel frame, and we use gypsum board to make the inside part of the wall, and the gypsum board is also able to be used for the spraying the hempcrete. and then we spray the hemp, and we use the render to finish. You can see that in this project we used the wood frame and the steel frame, and the wood is totally inside the hempcrete, and the steel frame is just 5 centimeters inside the hempcrete. In this case, we consider that the hempcrete will bring all the humidity, and we have no problem with the steel frame. So this is the building time. Here, both the wood frame and the steel frame. Here you can see the gypsum board on the wood frame, and after that we have the spraying of the hempcrete, and it's around 500 square meters, and in this building, the hempcrete company, they spray the hemp in around 1 week and a half, but after 3 days we stopped them because they go too fast, and we had so many points to discuss with them, and yeah.
So in this case, you built the inner shell and used this as the stop, and then you put the hempcrete on the outside, and then you plaster it afterwards.
Yes, exactly.
Okay.
And in this picture, you see. Sorry. In this picture, you see on the left, you see the outside facade.
Yeah.
And front, it's the wall
between
two buildings. So we
understand. That's why I asked it here, because I got the picture from actually that the hemp was put out from the outside, and you use the inner gypsum wall as the kind of stop for the hempcrete.
Exactly.
Yeah, so it's super efficient.
Yeah.
Good.
Yeah. In this case, we get 27 centimeters hempcrete for the outside walls on the facade, and for the wall in between neighbor, it's just 14 centimeters. Here you get two pictures about the rendering and how we manage hair tightness. So it's the render which is in charge of air tightness outside the building, and you can see a blue netting. Thank you. Blue netting. So this netting is used to be sure that between the render and the wood frame around the window, we will have no crack.
Okay, right. I get it.
To get the hair tightness. And this is important point for us. We discovered this point studying this building. This is the LCA life cycle analysis of the building, and we consider three different cases, and we compare the global emission of the use of the building, which is in gray here, and in blue emission of the construction. In the first column, we get the construction, common construction at the time just before the building of this project. It's using the former regulation. So you can see that there were many emissions for the using of the building. The second column corresponds to the way we achieve energy low energy building in this time with common solution. And you can see that blue and gray are exactly the same, which means that we have at most the same emission for construction and for using of the uses of the building. And the third column corresponds to what we achieved with this project using bio-based materials, which means that we were able to decrease the emission. And it's really interesting because I think that today it's quite difficult to reduce emission of the building unless you be able to use totally renewable energy and renewable materials, but we will need lots of technology, and I'm not sure it will be finally positive, but it's certainly more efficient and easier to use different materials for the building.
If I may, I would say one point here. If you look how low the embodied energy is in the building on this build, imagine what it would be if they had chosen a wood frame instead of the steel frame.
Right.
Yes, here you've got the detailed emission of each part of the construction on the bottom diagram, and the two blue columns correspond to the what we call the gros œuvre, is in France is the foundation in concrete, and the steel frame for the second column. So we could certainly achieve more efficiency building with wood. It's the next time, the next step for us.
And the thickness of the
also,
construction.
Also using what we have here in the room, which is a glass foundation, the Qualian foam glass foundation.
Right.
Combines the foam glass foundation with a wood frame with a hempcrete insulation. We might just be able to get carbon negative high-rise building.
Yeah. That's interesting. Yeah, we are building the wooden constructions that are built now in Sollefteå. This high-rise is rather interesting also. So you can, the combination, if you could combine high-rise structures of wood and hempcrete, that would be fantastic.
That is what we're looking to do.
Yes.
We're looking for the project, but we
I'm all in. I'm all in. I'm all in. Yeah.
And with high rising buildings, you have the added benefit of this not being flammable. It's not.
Yeah, right. No, I mean, it's, even though it's I mean, it's better when it comes to fire than traditional constructions when you come to wood nowadays. I mean, it's fantastic how they have developed construction methods and so on. It's really interesting.
I go forward, or yeah. Okay, so I go back to the 10 houses in Les Loges en Josas, just to show some picture of the building time. So this it's 10 houses with just concrete for the foundation, and also for the inside walls between houses. And then all the structure is in wood, and we sprayed hempcrete from outside, still using gypsum board inside. Gypsum board is just a bit less efficient than if we use a render inside, about thermal hygrometric regulation, but it's not too bad and able to let vapor transfer possible. So this is on the left side, this is the wall detail. We get 28 centimeters of hempcrete, and the U value is 0.29. And in the roofing, we also get around 30 centimeters, but the U value is 0.21. In fact, we use less lime for the hempcrete in the roof, which means that it's more efficient. And the main point with hempcrete, as we see it, is that you know that you can understand that the thermal envelope could be outside of all the structure and connect easily the roof and the walls. Here we could even have a better, less impact of thermal bridges if we just had a little more higher construction.
Where is this? Is this also close to Paris, or where is this located?
Yes, it's in the west of Paris, around 1 hour, just near Versailles.
Okay. It would be interesting to get these addresses, because I intend to go to Paris as soon as this shit is over to visit one of my really good friends, and then it would be nice to go and see these places.
Yeah.
Well,
so the addresses would be nice to have.
Well, we can give you the addresses, but we can even maybe keep in touch, and possibly you could have the possibility of visiting a building site.
Yeah, that would be super. That would be super interesting. So I'm all in.
Okay, I will show you. We have a building at the time, maybe 2 or 3 buildings in which you can go to visit, which could be interesting. So this is the same work about emissions, carbon emission, but we use a 4th column in which we compare our project with a common project using renewable energy, and it seems to us that it's not a good way, not good enough as could be bio-based construction. So this is all the detail, and in this calculation, you can see the green column, and the green columns correspond to all technical equipment in the construction. So this is really important, and we should find way to decrease the place of all this equipment in the.
But how is the regulation in France? Because here in Sweden we have regulations that says that we should have this much ventilation, and we should have.
Yeah.
So is it the same in France?
Yeah, it's the same. Yeah. We still have to work a lot to understand how manage ventilation differently.
Yeah.
Probably using the best could be sort of double flux ventilation.
Yeah.
Yes. But naturally.
Yeah.
It could be really interesting. We are looking for electricity, but or maybe have its recuperation and some way to turn to temperate air inside.
Yeah.
So it's it's a job. It's a big work to find solutions. This is a small project in Paris. It's a refurbishment of an old building of the 18th century, just in front of Notre Dame. And we used the hempcrete for old the insulation of the old walls. It was exactly as the first case I show you the first time we meet the hempcrete, because we look how to be able to renovate this old building and be sure that we won't create pathology after our work on it, and be sure it will be able to work for a long time. It was a big work. We had to change all the slabs, all the structure inside, and we use here hempcrete inside the wall. So this is the detail, upper detail. We use 10 centimeters hempcrete for the inside part of the wall, and outside we get lime rendering with 4 centimeters of hygrothermic render using hemp and lime. These are the both. On the left, it's the hempcrete, and on the right is the hygrothermic render. See, you have seen it also, and this is the render with the hempcrete, the hemp. So after that, we finish it with lime render, traditional lime render. As I show you on the first case, we consider here 3 different cases. The first one is how it was before. So there were no insulation, just the wall with stone. The second case corresponds to how we used to do commonly in France. So we just put mineral wall inside. And the third one corresponds to what we achieved using hygrothermic rendering outside and the hempcrete inside. And what we are really proud is that you can see that from the existing time and after our work, it's looked quite the same, but just more efficiently. There is a quite more different solution when we use the current or common solution, because the wall change the physic condition. It will be exposed. We also had special attention of how we go to solve the solution around, to solve the thermal bridges around the world. So you can see that with the hygrothermic rendering, we were able to go until the frame of the windows, and we also use a small wood wall plaster, just to be able to put some insulation around the the window and get the finishing continue from the hempcrete until the window. So this is another project, but there is no hempcrete here. Just it's a big theater in which we get natural ventilation, and here you can see on the section the air coming inside the building, under the ground floor, and going out in the chimney on the roof. This is, I think, really interesting. We wait to be able to work with this kind of question with hemp, because we are sure it's really important to work about breathing buildings. And I'm sure that skyscrapers or building will be really efficient to make this. We had studied, it was really nice pictures because we had studies in a glowing laboratory, is it correct?
Yeah.
Just to check what will happen with the air movement in the building. So I'll just go forward. It's also nice building, but without any hempcrete. So this is another building we achieved with Barrault Pressaco, which are two young architects in Paris. We built it with stone. Here you can see the design of the facade in stone, and the insulation of the building is made with hempcrete. And here you find the detail of the facade. So you get 30 centimeters of stone and 10 centimeters of hempcrete, which is really interesting because it's my brother who was in charge of thermal calculation, and when he told me that we are able to use only 10 centimeters, I asked him to check the calculation because I can't believe it. Hempcrete is not so good insulation material. It's quite half of the efficiency of usual insulation materials, which means that it's like we achieved here a building with only 5 centimeters of mineral wool, and this is important. We achieved here a building conform to the French regulation and the climate plan of the city of Paris, which means that the consumption should be lower than 50 kilowatt per square meters per year. But you see that the thermal resistance of the wall is just 1.58, which means that the U value is around 0.60. It's really a bad project, and sometimes young engineers are calling to our office and ask us, I can't understand how is it possible to achieve it, because architects have seen the project and they want to do the same. So they ask their engineer, please, look, it's possible. But people don't know how we succeeded. in fact, it's quite simple. We just make hard calculation of the all heat transfer in the building. We check all thermal bridges. We check the heat, the sun heat storage inside, and we use the combination of the stone and the hempcrete, which are two material able to create continuity, continue capillarity all for all, which means that the vapor transfer will be easy all around. And we also use wood panels of laminar CLT, cross-laminated timber, for the slabs, which means that the connection between the stone structure outside and inside structure of the slabs, it's not too bad, because wood is not too bad for it. You can see that the value for the thermal bridges is 0.09, so it's quite good. Yeah.
I just saw the time, and I'm sorry I have to go because I have a meeting within a few minutes and I have to prepare a few things before. So this is super interesting, and I'm so grateful I could join in this, and I will try to communicate this with my coworkers in my office, and let's keep in touch, Sam.
Yes, of course.
About this, and thank you very much, Peter. And I don't recall your name. I'm sorry, Mr.
Laurant.
French.
Laurant.
Okay.
Frederick, you can call me when you come into Paris, because we will bring you to some sites.
Yeah, that would be very interesting. So I definitely will keep in touch. And this last project looks fantastic. Also, a very it looks super beautiful as well. So that's kind of nice to see it in so many different ways. And I really enjoyed seeing the modern way of building also. So it's important that we can get it in a modern, efficient way of doing modern production kind of thing. That's the way of selling it to our clients, I guess, also. Yeah. So I'm all in. Thank you so very much.
I'm sharing all the contacts, so
yeah, that's perfect.
Frederick,
it would be nice to have something to show the others on the office. So if we can get some the short presentation you had, Peter, to show that for the rest of our co-workers would be very nice, I think.
I think we will bring along Patrik Bengtsson too, your colleague from Malmö, who's built.
Yes. I don't, because of this fucking Corona thing. I'm sorry to say, I haven't had the pleasure of meeting him, because he also had a presentation about his project, and unfortunately I couldn't join there. So, but this was very, very interesting. Thank you very much. See you guys.
We'll see you, Frederick. We're just leaving you with one last picture.
Yeah.
It's Laurent's latest project. It's a 50-meter building, 14 stories in Paris.
Oh, now you're talking.
So we'll leave you with that. We'll tell you more about it later, and we'll keep in touch.
Yeah, absolutely. Take care. Thank you. Bye.
Thank you. Bye.
Bye-bye. Yeah, just to show the latest project, but if you have still a few time, I can just show you the latest. So this is you see the pictures of HampaKalk, still his project with stone, and the facade in stone, which was really incredible. When you cross the road, you can see the stone and you can also see the wood slabs because we let it present in the apartment, and you get the wood and
what number is it?
62 overcount. And inside the building, you have the handcrete with the line render inside, and this you can see the handcrete just before the finishing, and the wood is let like this.
And it's sprayed here as well.
Yeah, sprayed inside. Yeah.
And only the stone is bearing. It's no steel beams.
Yes. We get just some steel beams and steel frame.
Windows.
No. The windows,
Inside.
The interior structure.
Yeah.
Interior. Yeah. All right.
In the facade, you just have the stone, just a steel
I saw it in the
L-beam,
picture.
yeah. Just to put the slabs and handcrete, and that's all. Yeah. We went with Simon. We met in Paris on this project, which it's another housing building in Paris, in north of Paris, still in the same area, with the same architects, and here you find the wood frame. It's a concrete slab and concrete structure inside because of economic issue. We cannot succeed to build in steel or in wood. We have no enough money. And you see there the handcrete, and as you have seen in the first images, there are short, small fields in which we get the handcrete. In this work, we managed to get cold air in the short courtyard, crossing all apartments and replacing the hot we will get on the windows with the sun. And the later one, and the last one, is a 8-story building, still in building time west of Paris.
I think, but don't we refer to it as 9 when it's 9 stories? In France, they say the bottom floor plus 8.
Yeah, then it's 9.
That's 9.
Yeah.
It's a 9-story building.
It's a 9-story building for you. Yeah. 9 levels building, exactly. And we use steel concrete structure inside and wood frame for all the facade, and the handcrete was sprayed on it. We just prefabbed here the wood frame, but we did not succeed yet to get prefabrication of the wood frame. We are working on it today. And we plan to do, this is for the Olympic Village. What we are studying today, not this one, sorry. This is the Olympic Village, in which we work on building 6 levels that we will plan to prefab totally, and this is a building using a concrete core and wood slabs and wood structure and hempcrete for the facade. And the last one is this one, which is in a building in stone with hempcrete inside, as we first achieved it for Overcombe.
Yeah. And where is it?
This is just south west of Paris.
Yeah.
You see the peripheric on the right.
Yeah.
And it's in the area where Jean Nouvel is actually building 2 towers.
Okay. Yeah.
So it's just you see the here is the tower of Jean Nouvel.
Yeah.
So we are just 100, maybe 200 meters from it.